Okay. So the class is live now. So if you don't mind, we are going to continue to respect. Okay. So you can still see my screen, right? Yeah, as I can see that you can see it. So okay, what a map does is a map records it. You use a key. As I said, you use a key to access a value. It's just like if you've been in university, I'll say is think of it like your matric number. So if they want to get your results, exactly, that's a very good example. If they want to get your results, say the school has a site where everybody's result is found, and you want to get your particular results, what's the unique thing you are going to use to get your results? It's your matric number, right?
Yeah.
Now, that your, that your matric number can be considered your key, while the results you get to see after you put it will not be considered your value. Meaning, you use your matric number as your key to get access to that particular value. Do you understand? Very good. So, in the same light here, in a map, you use the key is used to get the value. So, if I want to get the book that was borrowed by Samuel, this let's say this is Samuel's wallet address. I want to get the book Samuel borrowed. I'll have to supply his wallet address as the key to get the book as my value. That's what a mapping does. Do you understand? Exactly. Very good. So this what you are saying here, what I've done here is a one-to-one mapping. So it's like one contract address to one. That's why I mentioned that there is a flow in this thing. Because if someone is still with the first book he borrowed and he comes to get another book, he's now going to replace this book with the new book he has gotten. And there will be no record anymore that he's with this book, and the storekeeper will not be able to find the book there quickly. I don't know. Okay. This is like this is logic. So I don't expect you to understand right now. What we're trying to establish here is we're trying to write Starknet smart contract. So if you don't understand, it's okay. But there is something I can do about this. I can actually say that if anybody is with one book currently, cannot borrow another book, which will actually be a very good book for anyone who understand. So teaching you how to do your job. Anyway, we mentioned the interfaces, we mentioned the contract, the module, you have the storage here, then you have the constructor. There is something extra that is important, but I have not mentioned it yet. It's events. Now, um, events are used to tell the outside world that this thing has happened within this contract. Events cannot be accessed by other contracts. They can only be accessed by, say, front end, back end, whatever, any other thing you build can index events. Events is not for contracts. Events is like sent outside. So, okay, let's say someone borrows a book here. I can emit an event called book borrowed with the details of the book that was borrowed. I can mention the ID of the book person that borrowed it. So I have actually not put my events, but I think events are going to be the last thing I'll add here. Okay, okay, let me add them. And if you actually have your workspace set up, you don't forget that you can actually follow along, and if you have a problem, like you can just see it. If anything is not working as expected. So an event is decorated with, as usual, the event decorated. An event is basically a struct. An event is a struct. So remember on this particular struct, we have to derive some traits. We derive copy, drop, set, and spare. So on this event struct, we are going to derive a few traits too. I'm going to derive drop. These are the traits I'm going to derive. Things like they are what is actually an event is not straight. An event is like and the event is must be named events, just like the storage structure must be named storage, and the constructor function must be named constructor. So that's how it is. So you have your events, and within this event you mention the different events you have. Okay, Samuel, you have a question. What's the question?
I mean, these decorators here, so we have one for events, that's which identify that particular function as an event. Then there's
Yes,
another one, the drop and Starknet event. What's that line for?
this particular drop line is so that you can return this value. Do you understand?
Okay,
I mentioned
that's
that
the return.
in these Rust like languages, like any small thing you do, you have actually destroyed the variable, something like that. So this copy, drop, and these three especially, they are so that you can
Yes.
use, that's so that you can actually use them like more than once without destroying them. They serve different purposes. But I hope
Okay.
you get the point.
Yeah, yeah, I get the point. Thank you.
Any other question? Okay, is it you ask the you want to ask the question? What's the question?
Okay, sir. You had initially said that event is a struct, but then suddenly you said it's an enum. So how did you determine that it's an enum? I want to know that.
Okay, the event is what you have here. This is your enum event, right? And in enumeration in any programming language is just it's like an object, but it can only have certain values. It's not of a type. How do I explain it? Okay, you know how you know how booleans are. A boolean can only have two values. What are the values?
True or false?
Exactly. So what you call boolean is actually an enum with just two possible values. Think of think of it as think of it as um the there are there are thousands of numbers, right? From zero to whatever you have. But a boolean is just an enum that implements only zero and one. That's like what an enum is. It implements only a certain number of values. Do you understand? You are going to see it here. That's like one good explanation of enum. So the events implemented within this enum are structs, but the event itself is an just hold on, you're going to see it. So the first event I'm going to say is book borrowed. Mm. So timestamps in Cairo are always type U64. Then after I've done this here, I'll come under this enum. That's how you implement events in Cairo. If the event is not stated here, then you cannot emit it. I'm going to define another event. Let us just ID type now. And then I'm going to make each of these variables public. Then I will the compiler is complaining that all my events start with the same prefix. Oh well. I'm just changing the naming convention so that the compiler is option. So well implemented events. Important thing to note: this event decorator is only giving us is only giving us while the rest just have derived scripts. I'm sure you understand. And since we have completed like basically every other thing, we can go to our logic implementation right now. Any question before we start? Any question? Hello.
Go on, Chief. Continue. Continue.
No, sir. No, sir.
So it's either I'm not teaching well and everybody's confused and nobody knows what to ask. I'm teaching too well and nobody knows to ask any question.
I'm just really suffering from network issues, so I'm finding it hard to hear you, but I'm understanding some things.
I have a question, but it's not related to the question. I wanted to ask something about. Can I create another? Is it mostly you'll be writing code only on this lib.caro, or can I create another file?
You can create another file.
Is there any way of folder structure that okay, this is the way folder is being structured, something like that?
Just whatever you do, just make sure it's inside your source folder, and then make sure the module is made public. After you make it public, you have to come to your lib.cairo to expose it so that it can be accessed by other modules.
Okay.
You are going to be seeing that on maybe week 4, week 5. But okay, now this is the implementation, and I actually forget the decorator that is here. Always forget the decorator that's supposed to be. But what you're supposed to have here, okay, this implementation block is supposed to. Oh, can I do an overview of the tools? Sorry, hold on. Yes, I think I've done that so far now. I'm about to talk about the implementation block that I just wrote. So what this thing is supposed to do, this is supposed to give the logic for a particular interface. Do you understand? And the interface I defined here is this iBookstore. So this implementation block is going to be the logic of this iBookstore. So that's why I call it from Skillup Summer of iBookstore. Now, once I do this, it's the compiler starts looking at this iBookstore to check what I've implemented and what I've not. That's why you can see red here. If you hover, it say not all traits are implemented, missing add book, remove book, borrow book. It's basically missing all the functions that are listed inside here. Is that clear? Is that clear?
No, sir. No, sir. I didn't get you.
Okay. Let me come again. This we have passed the point of defense and everything. We are coming to the actual logic now. So this implementation block, what an implementation, what's supposed to do is that it's supposed to implement the logic for a particular interface. This is the interface defined for this contract. These are the functions that it's supposed to contain, right? Now, in order to define the logic, we need to first see what interface we are implementing this thing for. So now I'm going to write it from the top again. For implementation, I'll call it Skillup Bookstore of iBookstore. Once I add this iBookstore, it's going to look at iBookstore. Okay, I have to add what type? Contract states. So it's going to look at iBookstore. Inside the actual iBookstore, there are how many functions? 7, I think. So the compiler is shouting at me now that I have not implemented all these traits. Not all trait items are implemented. Missing, add book, remove book, borrow book, return book, get books, get inputs. Do you understand? So in order for the compiler to stop shouting, I'm going to have to implement all the trait items. So one thing I do first, I'm not going to train you like this. I'm going to train you. I'm not bad one. So I just copy everything that I see. I'm going to get errors in bookcase. I'm going to paste it here. And this is not supposed to be. This is contract states, not C contract states. I mentioned in the previous class that whatever you are saying here is just a representative. This T contract states. But let me show you now. I can decide to replace this thing with just T. You can see that as I'm putting the T, all the red is removing. So whatever you are saying here is just a representative. Like it's just represent what type is inside these traits. But when you're actually implementing your contract, it has to be contract states, not C contract states. So I'm just going to remove. Again, I'm that terrible that teaches you bad habits. And lastly, I'm going to replace the what was it called? Semicolons. I'm going to replace them with brackets. What are these brackets? Is this square brackets? I can't remember. But do you understand what's happening? Do you understand what I've just done? And the compiler is no longer shouting at me. Is there anybody that is lost?
So I'm not seeing your screen.
Oh, Jesus Christ. Sorry. Hold on.
I can see your screen. I can see your screen.
Yeah.
Maybe
I'm supposed to use my resolution. So I'll be very good. Is it better now? I think it's much better now. Correct? Oh, so I've been not sense. Okay, now you're seeing it. Let me go over it again. Do I need to go over it? I feel like I need to go over it. Yes, let me go over it. Well, I assume you understand what we did in the previous class. This struct, this interface, and everything, even up to the events. Okay, I'm going to start with the events. What we started with today is we implemented events, and you can see decorators all around you, so it's not strange. There's a decorator for storage. So in the same way, there's a decorator for events, which is called events, not like the storage is called storage. And event is an enum. I derived some traits on it so that I can use enum. And then what's yeah. Okay, I implemented the particular events that we are going to be able to emit. So we are going to emit an event when someone borrows a book. We are going to emit an event when someone returns a book. We are going to emit an event when someone adds a book, and then when someone removes it. I don't think there is any other event related. But after defining these traits, then I come inside here and put them here in this manner, just for the sake of for safety's sake, in order not to make any mistake. Just make the key and value the same. So book borrowed, book returned, book added, remove, book added. Do you understand? Is there anyone that did not follow that part? So now everybody is liking faster because you can see my screen. You should have fixed it. Now I'm happy. Okay. I'm going to remove the application topic. After everything, the last enemy we need to defeat is implementing the actual bit, and it's done within an application block. So if I'm going to write it, so we have code info don't edit student of, then I'm going to mention the traits. That's the trait, I mean the interface. And the trait is this iBook store, right? I've imported it here already. So I'm just going to use this of iBook store. And the type is contract states. Just like we have here. Then I'll open this. Once I've typed this thing, I've told the compiler that I'm implementing this iBook store interface. That's this interface you have here that contains this table function. How am I saying this? So the compiler starts to shout at me immediately. Says not all trait items are implemented. Missing add book, remove book, return book, get book. So it's basically missing everything that is inside it. That's basically missing all the functions that were listed within this place. And no, mind you, any function you write, it must be exactly as it is here. It must be exactly as it is here. So even down to argument names, it can be called title here and be called let's say I don't have another word, but get the point. You can't call this author here and call this writer when you want. It must be exactly as it is. The only difference is what to be here. The self, what to be there for the self, not called contract states. No longer whatever is here. And then there is one more thing I didn't mention the first time. We have to add a decorator to this. It will not have to. It depends on what we actually intend doing. So I intend making these functions callable from the front end. So like when someone builds a front end, they can actually have access to these functions that I'm defining. If I want it, since I want it to be callable, I would like it to be added to my API when the compiler is compiling. And if I would like it to be added to my API, I'm going to have to put a decorator. API. I hope this yes is correct. So this is the decorator I'm going to have to put. This embed v0. It now make sure what is here is added to my API when I eventually build my contract. Is anybody following? Is there anybody that is lost?
Now, Professor, this ABI underscore embed underscore 0.
Yes.
Like, is this like or you did it because of a particular reason, or is this normal by default, or you just put it there because of a particular reason?
As I said, it depends on what you want to do with this implementation. I can decide that I don't want this, this thing to be callable for my company. I don't want these functions to be callable at all. Like, it's also possible to say, okay, in some cases where you use components, I actually don't expose the component functions. Instead, once I write the implementation for the component, I use them within other functions. Do you understand? Instead of exposing it to the front end directly. But once I put this line, this decorator ABI embed this, it now makes sure when this contract is actually building, like when it's actually building, the functions are added to the ABI. I know it's only when you have the ABI you can call the function. So in most of what you'll be doing, at least right now, you are going to be putting this decorator. So make sure you don't forget this. Don't be like me. I have some kind of bad character. I will not call it bad. But small things like this, I don't remember them. Instead, I go to contracts that I've written before and just copy them. Like a small line like this. I don't count this. But right now, it will be good for you to remember everything. So again, I'm just going to copy these functions that I have here. Because I'm actually a very lazy person. And I'll come down here and paste it. And it's contract state we have here. So I'm going to change all these two contract states to contract states. And allow in this. Then I'll change all these terminal semicolons. So this signifying that I want to write a function or a logic block. Is there anybody that is lost? Ask a question now. I'll not say oh, forever remain silent because anything to this question, still ask a question. But if you are lost, ask a question. Okay. Is it okay, Mario? What is your question? Mario, can you hear me?
Can you hear me? Can you hear me?
Yeah, I can hear you.
Okay, so what's the difference between the contract state and normal contract state?
The T contract state is just okay. Let me as I did it before, but I can decide to. This is just this T contract state is just what is in this trait. What you have within this angle brackets, I think it's called an is a particular type. So you can give the type any name you want. They call it T contract state just to signify that this thing is actually for a smart contract. It's not any trait we are writing. That is, well, I can actually decide to just call it T. What if I call it T? I can change everything here to T, and it's still going to mean exactly the same thing as always means. Do you understand?
Yes. I think I understand.
So, but once I put it inside this implementation block, it must be called contract state. Do you get?
Yes.
Okay. So, any other question? Oh, So the first thing we're going to implement is add, and this one is actually going to be very simple. Okay, first of all, we said that only the storekeeper should be able to add a book, right? And the storekeeper's address is stored. We made sure within the constructor we stored the storekeeper's address. So I'm going to get the color of this function. The only permitted color of this function is storekeeper. Am I correct? Oh, am I correct? Can you hear me? So the only permitted color of this function is the storekeeper. So to get the address of the in a Starknet contract, to get the address of the person calling the contract, you have to import a function called get color address. Everything is actually simple. I'm not doing advertisement for Starknet, but you prefer Cairo. So I'm going to say let color is equal to get color address, and this gives me the address of whoever is calling the function. Then next, I'm going to say let storekeeper be equal to self storekeeper dot read. So this the type address. So we have to make sure the address, the color is same as the storekeeper, right? So we use assert. So assert that, sorry, color is equal to storekeeper, and then you add an error message. Color not permitted. So this means that you make sure color is the storekeeper. If not, the function is going to revert with the error color not permitted. Are you following? So once that is done, I can now say let book be equal to book. This is the purpose of the job. Let's book equal to book. I'm defining a book here now. That's why, and it's complaining that it's missing these members, missing member ID, number, title, and okay. So, I've actually not planned for my ID dates. I mentioned in this place that I'm going to start the IDs of the books from 1. So what I have in this book counter, what I currently have in this book counter, will be the ID of the next book counter. So I'm going to say let's book ID equal to sell dot counter dot date. So when I come here, I'll say ID is book ID. What else? Title. I can say title is title, and I can say author is author. But this will be redundant. Then I remember you have to put a semicolon because this is actually still like one line. Instead, I can just see if the key and value are the same. In this case, you can just do this. It's allowed. I'm sure you must have seen some things like this in other languages. If you have seen other languages, if not, now you know something new. Then when one important thing people miss is that when they read from storage. You forget to write back to storage. Now I've gotten book ID. The book ID is the ID for the current. If I don't update storage, when I come add a new book, it's going to use the same book ID. So I'm going to update storage now. And it's best to update storage immediately so that I don't forget. At least for me, I love to update immediately after I read. That's if it's something I need to update. Like this storekeeper, I don't need to update the storekeepers on this. It's the same storekeeper. Let's go down. So self dot book counter dot write book ID plus one. So that the next ID is going to, since the first one was 1, so that the next one is going to be 2 when we want to add a book next time. Do you understand? Will anybody follow? Is anybody lost?
This particular place now, I just lost.
So, you mean in updating the storage?
This one I just did. Self dot book counter dot write. Okay.
Yes. So
You are
storage
putting the
variables. Sorry?
You are creating a new ID for the book, right?
Yes. What I did here first is that I read the book counter. This book counter just keeps track of the number of books you have. So when I planned the contract in the class, I said that I'll initialize this with 1, so that so since this is 1 now, the book ID of the first book I'm adding is going to be 1, and then I'll increase it in that same block, so that when I come back to add another book, the book ID of that one will be 2, and I'll increase it to 3. That just like that. Do you understand?
Yeah, yes, I guess.
If I am forgotten to update this storage now, after doing this, when I come to add another, what this variable will be is still 1, and instead of adding a book, it's going to overwrite this one that I added. Do you understand? So, very good.
Yes, I get you, Chief. Thank you.
Then, yeah, sure. I like the same. Then, what else am I supposed to class from the storage variable? I'm supposed to add something to books, right? And this is mapping an ID to a book. So I'm just going to say self.books. By the way, how you access maps is different from how you access ordinary storage. How you access maps is just dependent on the particular syntax. And this is my favorite syntax. There is a reason I imported these things and put this storage pointer right access and storage pattern. This is just syntax that I love to use, and I think everybody should use this. I think it's very easy to understand. So let's cell dot entry book ID, then dot write. So this is the key and this is the value. Now the entry is the key, and then you write the value to the key. So I think the syntax is like very easy to understand and very easy to work with. It's very convenient. You can't get confused. But do you understand what I've just done? I follow. Remember that the map is between a U8 and a book. That's the book ID. And so this book ID is U8 and this book. So the next thing I'm going to do is I'm going to create an event that I've added. So self dot emit. What's the name of the event? Book added. And the compiler will shout at you. So what was missing? Book ID. What else is missing? Book name. Oh, I was supposed to call it title, right? What else is missing? Book author.
Like a boot auto. Boot auto.
Okay. And then the last thing that is missing is timestamp. Sorry, let me update this thing. I want to update this thing. I'm going to call it title. The same thing here. Then, in order to get your timestamp here, you also use a system call. It's let me system. Not really a system call. It's called get block timestamp. So there are many ways to do this. I have to update this. So I can just say timestamp, and then I'll call this function here. Because calling the function returns the timestamp. Or I can be a boring person and say let's timestamp equal. I mean, it all depends on your use. Sometimes you might want to get a particular time. It all depends on your use. And then I can just do this here. It also works. Will you understand what I've just done? Is anybody lost on this implementation? Anybody? Ask a question now. Or remain silent until you get too confused and you have to ask. Anyone? That was beautiful. I see great smart contracts in the future. Okay. There's something I'll do here now. I want to add something to this. I'm going to add defaults. And there's a reason I'm adding this. You are going to see this. So I have completed this add here. Again, only who can remove a book, still the storekeeper. So I'm going to get the color again. You can actually do this, although this is less clear, but you can just do assert get color address is equal to cell.storekeeper dot reach, and then you put your error message. It's also going to work. But should we do this? We can actually do this for long next. I'm just going to do it so that we are going to see different ways that you can get something there, or that you can get something there. So I've collapsed these 3 lines into one. Then we want to remove the particular book. So instead of there is more than one thing. You can either sell.
I think, or we can
Sorry?
check if the ID. We can check if the ID of the book is we want to
Okay,
delete
yeah.
is actually.
That's
Uh,
yes, that's also something.
also, are we going to like? Can we have access to this code like immediately after the meeting?
Yes, yes, you can.
Now, now book where is the code for now? My PC data.
It's done. So we can book, let existing. Yes, that's very good. Let existing book equal to cell goods dot entry ID dot get. Right. So then we're going to assert that existing book is not equal to. That's why this is the reason I did that first. So what this is going to say is since I've derived this default trait here, it means that no matter what number you put inside, even if you put an ID that does not exist with, there is a default book it points to. The default book it points to is a book with an ID of 0, a title of 0, and an author of 0. Do you understand? I think that's why I decided to start ID 1, so that 1 is simplified, so that a value is inside there is simplified that it actually exists. So when I do this now, I'm making sure that this existing book is not equal to that default. If it's equal to default book, then I know that the book does not actually exist. So I'm just going to put the error message. Mind you,
That means
there's
the
a
default has
sorry?
the default has an ID of 0. That's if the existing book ID is not equals to
Yes,
that, the default is 0. Okay.
exactly. So I've made sure the book exists. And then the next thing I'll do is now to actually remove the book. So I'm just going to say self dot books dot entry is the ID dot write and then defaults. So to remove a book, what I'll just have to do is change what is contained in the key to the default book. Do you understand? Do you understand?
Like you are updating the ID of the book to the default ID, which is 0.
Exactly. Exactly. Updating the value this key is pointing to the default,
Yes.
which is that 0. I can
0.
call it 0.
Now, how
So
is it going to be deleted from the blockchain?
it's not going to be taken from the blockchain. It's just not going to be returned. You don't exactly it's still
Okay, okay, oh yeah, that's true.
so now that I've updated it, I'm going to come down and emit the event. So So what am I to say? And timestamp. So I have successfully removed the book also. Is there any question? Any question? I have no questions. Is it triple? You don't have any question? Well, at least the class is interactive, I guess. If there is some appropriate. Seriously, nobody here has a question. Let me take the questions. Daniel, no question.
No, I just came back. My network is having issue. I wasn't seeing the screen last time.
So, other Daniel, no question. John, Kenichi, Mario, John Boston. Any question? Okay,
No,
so
so far,
just
sir.
raise no, so fine. Any question? Anybody? Is it okay? Just raise the hand. Is it just raise the hand?
No questions, sir.
So let me help you lower your hand. Your arm is bending by now. Okay. Let's just continue. So mind you, we are getting errors here because these functions are meant to return some things, and so far they are not returning anything. So the compiler is going to shout. We just can't satisfy this compiler. It's like if there's any okay, it was a joke of this. So the next thing we are going to implement is borrow book. So the logic for this borrow book is a person can come and collect the book from the store. And I'm not going to like do strict checks where the person apply and the storekeeper will have to give them. I'm just going to make it that the person can just walk in and collect the book, but it's recorded that this person is with this. Like this person in this particular wallet address is the one that borrowed this particular. That's what I'm going to do. I'm not doing to really strict check because this is our first smart contract, right? So let's just record his address. So let caller be equal to get caller address. By the way, I'm just going to mention that people writing Cairo in this era, they are pretty lucky. When I was learning Cairo, all these suggestions you are seeing on my screen, I didn't see anything like that. Like it was really unique. I'm actually happy. So let's get caller address, right? So it's very easy. All we need to do is let's get the book. And we're going to make sure the book actually exists. So we can actually copy the logic. We can actually copy the logic. So we are making sure the book that this person wants to borrow exists. You can actually change this. You need to change this. I wanted to change it. You cannot borrow a non-existent book. You need to change it. So if the book exists, I'm just going to say self dot length books dot entry color because the color is key dot rights Oh, that's another thing we should do. I remember what I mentioned at the beginning of this class, that we should make sure that once the person has borrowed the book before, he cannot borrow another book. So first of all, we need to read the map to see whether this scholar has borrowed the book before. So let's already borrowed book. Sorry for my long variable names. Equal to self learned books dot entry color dot it. So let me hit start. So those it, right? Then again, we are going to make sure the already borrowed book does not exist. Now is the default book, which is 00 book we mentioned in the previous function. So we're going to assert that the already borrowed book is equal to the default. If not, color into. So is there anybody that does not understand what I just did here? Anybody? Okay, is everybody okay with what I just did? Does everybody understand what just happened? It's just someone that's on. Does everybody understand what I just did here? Okay. Let's say I'm that in the teacher. So yeah, with John Bosco, what's the problem? Please follow your mind and speak. Okay. First of all, I mentioned earlier that in this map here, what I used to explain how a map works, I used your rate number and your results. So that's it. And your results. Right? So if in a school system, for example, if you want to see your results can be seen as a value. And the key you are going to use to access your results, your particular results, is your rate number. So if you supply your rate number as your key, you get your result as the value. Now, if you have another result, if this thing is one-to-one like this, if there's another result, let's say you do another semester and you are supposed to have a result for that second semester now. If they come again to write to this map using this key, instead of adding a cookie, it's going to overwrite what is here already. So in the same way, what I was like, if someone borrows it, his wallet address is going to point to that book that he borrowed. But if he comes to borrow another book, that new book is borrowing is going to overwrite this one. And we are not going to have any record of this thing. We are not going to know that this book existed in the Bible. But who is the thief? We don't know who is the thief. you understand? I sincerely hope you understand. And I should actually change this. But when we get this, when we get to getting but my solution was that instead of overwriting this thing every time, instead of overwriting this every time, before someone borrows a book, we should make sure that that person is not holding anything currently, that he has returned all the books he's holding, so that this thing is empty and we can just write one book onto this place. Do you understand? Numbers. Do you understand? Yes, I do. Okay. So let's emit the events. So self.emit all the event storage, book borrowed. And what does it have? It has book ID, it has borrower, which is the column. I can as well change every color inside. So no need to do it. No. I mean, I could change this to borrower, call this borrower, call this borrower, and not put anything there. So, don't want to do it. Then timestamp, get block timestamp. So I emitted the book borrowed now. Is that clear? So that's three functions we have implemented there. You are on fire. Anyway, let's implement return. It's going to be pretty much the same, similarly to this. So I'm going to copy this one. So I told you I'm a lazy coder. So we are getting polar things. We are, we get to, let me call this borrowed book. So we are accepting, okay, let me comment the sense. Yes, we are accepting that the borrowed book, that this guy has actually borrowed a book. So the borrowed book is not equal to the default. So polar defaults for the default. Do you understand? Do you understand what I'm doing? The person wants to return the book. So first of all, get the book he has borrowed. Yeah, another thing we can do is let's but this is not necessary. We can also make sure this is like very, very unnecessary. I'm just looking for use to decide. Exactly, since I've made it that a person can only hold one book at a time, there is no need when you want to return a book, you need to specify the book you have returned. There is only one book you can return.
Yes, yeah.
Do you understand?
I think it's just to check if the book
Is
returning
exactly,
was the one you actually borrowed.
exactly. So I don't know what error message should I put? Suggest something. What error message should I
Okay, if the book is not the book you borrowed, I think you should return
Returning wrong.
ah, yes,
But
yes. That's okay,
technically
that's
not.
okay.
So okay, we are now making sure the borrowed book is not equal to equal. If we have this, yeah, okay. But what I actually recommend, since one person can only hold one book at once, is removing this ID. But, yeah, it's fine. Then the next thing we're going to do is we don't need this two lines. We do not need this two lines. Oh, oh,
Like maybe
okay, well,
if the person returning
okay.
the book
This
is
line that
actually
is here
the
now,
user,
this
if the
line,
person returning the book
this
is
line that
actually
is here now, this line that is here, we've actually done the exact same thing here. Because if you look at it, this borrowed book is like supposed to be equal to this existing. So we don't need this thing.
yes, yes.
So the next thing is to update this map. So self.length entry color. Since the color is returning a book, since the color is returning a book, we are just going to default. So that the color does not hold any book anymore. Do you understand? Do you understand? Okay. And then I'm going to change this. I think it's the exact same. It has the exact same process. So that's how many functions I've actually implemented all our right functions. So that's a win for us. The next thing is to implement our read functions. I mentioned that there is something I want to change here. In this get length book, it does not make sense to just see a list of books and we say that these books are not currently held by the store, that they are held by outsiders. So instead of just an array of books, I'm going to return them. I assume we did data types last. So I'm going to return an array of tuples. And these tuples, what I'm going to have is contract address and book. So this is like the person that borrowed it and the book he borrowed, instead of just having the book. Do you understand? So I'm glad you cleared that up. And since I've changed something in this interface, the compiler is going to shout at me. So I'll change it here too. So to get books, we have here, this is where our book counter becomes important. First of all, the one thing I should explain, I don't know, it took me a while to figure this out because Cairo, Cairo was my entry into Web3. So I didn't understand. in read functions, in functions like this, there is actually no color. Like you don't use your wallet to read from the blockchain. You only use your wallet to write blockchain. So doing something like get color address here is actually not going to work. It's not going to. There has to be another way. You can actually take in a contract address as argument, and then in your front end, you supply the currently connected address in order to read. Now, as if you want to hide what is inside here. But there's actually no color, so you can't do something with the sats and get color address and all that inside the read function. Took me a while to figure out. I eventually figured it out. So the first thing I'm going to do is I'm going to declare an empty array. Let's all books array dot array. And very important, remember that we can't change the value. Values in Cairo are immutable, except we do what? Except we add roots. Do you understand? Do you remember? In math? Can anybody hear me? Just to make sure I'm not disconnected. So all books are in. We have our book counter. So I'm not going to use the for loop here. For I 0 to be counter. This is supposed to be more complicated than this, right? I'm just going to use this. I'm in fact, yes, I'm just going to use this. Mind you, this thing is going to give you an error when you actually call it. It's not really an error, but it's not going to give as expected. But I don't want to start this. Okay, let me just see. This in keyword. This in keyword. When I say 0 to book counter, is like going from 0 to every book, like every ID before the value of this. So if the book counter says 10 now, this is 0 to 9. You understand? But then it comes to mind that the 0 book is actually 4. So I'm going to change this to 1. So from 1 to the book counter. Okay, let's current equal to cell books into I dot x. All books array dot append current. Yeah, I think that's all. So this is going to be same.
Why can't we just like return the books here? like at once, why do we have to reassign them one after the other to a new variable?
Return the books as
Like now, we have to like append each of the book back again into all books array, one after
yes,
the other.
so that we are going to now return this array at the end. Since what is expected is an array of books.
And we can't just run it by doing self.books. Oh, it won't work that way. Okay.
No, it will not work.
All right.
Like we have to read each entry. A map is not like an array that you can see, you can get all the foreigns. I think in Solidity it is like that, but it doesn't. It's not like that. It doesn't use that. I don't. I don't really. I don't really do that. But you have to read all the all the existing books before you can add them to this array. That's like just how it is. It's, so how to return the value of a function is just to mention it without the semicolon. So when I say all book array, it just returns the array like this. So the compiler has not shouted at it. Do you understand? The same way, I'll come here. Let's books. Lens books array. If you call array and declare an empty array, this is actually something. Oh, we can't get all the length. Okay, we can after. We can't. No, we can't. We can't. The reason we can't is that
Like, if you want to do that, you have to add another struct that's going
we
to
have
like determine
we,
was borrowed.
what I wanted to do is add something to this strokes. But I don't know why I don't want to do this. Like I wanted to add a holder to this strokes. So the holder can either be the stroke or someone that has borrowed it. Do you
Or you add
understand?
a variable to it.
Exactly. If I
get
add a holder here, I can do this. But for some reason I don't want to, because like I've demonstrated what I want to demonstrate. If I don't have to write a smart contract here. So I'm going to remove this and remove it from the interface while hoping to become this compiler is writing that. Just remove. So I'm just going to remove this. I hope you understand why.
Yeah, I get you. But in the future, instead of
Yeah.
adding a holder, is it possible to
Yes.
just add a Boolean value? Is borrowed.
Yes.
So,
You can. But if you add
okay, no
is
problem.
borrowed, you can't get the holder. You can only get whether it's here or not.
That you can't get the like user that actually borrowed.
Exactly.
Okay.
Since we are just writing the smart contract, we don't need to go into all these details. And there's an easy way to go. Once you start writing many smart contracts. So forget book. We are not going to read the book. So let's be equal to cell books dot entry id dot read. So it's very easy. I can just say book. You know something else you can just do?
We have to check if the
You
book
can just do
ID is
this.
actually.
Fine. You can actually do this on its own. But then yes, we should check if the book. Let the existing book. We go to cell books. Search existing book is not supported. It's for book does not exist. So if the book exists, return the existing book. Any problem? Any issue?
No. Like I'm just happy. We finally
Yeah.
did this.
Finally, with any questions before I continue?
It looks more is making sense now. Although compared to Solidity, I think
Yeah.
it will it will be very much easier to just to switch. Yes. I just need to like master the programming language very well. That's all
Syntax.
I
Yeah.
need to do.
To me, this is
Yeah.
actually better than Solidity. It's like no script, but it's like JavaScript and TypeScript. You know, TypeScript like helps improves your dev experience. So I think that's how I see it. Like, this is much safer. It's much more structured. Um, we have the Solidity. So, is there anybody that has a question before I think the next step? And I would actually love
So
to explain some more things. Many people are
so
living on
if I'm to understand that the way um Starknet smart contract works, or okay, let me just say Cairo in general. Let's say if we are
yeah,
using it to write a smart contract, first of all, we will need to declare an interface first. That's for every
yes,
single field or function. Then
yes,
those interface, that's those functions in the interface, will have to be implemented in the implements
yes,
in the implementation block. Okay.
yes,
Then how about the like? Okay, let's say it was implemented in the implementation box. That's each function. Now, where are those? Okay, I don't want to. It's
where
like I'm missing some. Where are we like calling those functions? Because definitely all programming language, the function is declared. It has to be what code.
oh these
We,
functions are exposed. They are they are not called from here. Do you understand? They will be called external, like from your front end or whatever.
yeah. Oh yes. Okay.
So,
Yeah, I get you.
so I'm just going to scrap build. Oh, I told you about my creation. Let me delete this.
Client, yes.
Yeah, I told you about our clients. Our clients cannot find any contracts here because we have not done scrap build.
Scrap build.
Hmm? Okay, something else you should do, sir, to let this card be finished. Scalp formats just to make your code look clean. But let the build complete. Now it's complete, right? I'm not going to scalp formats. Now it has formatted it. Some lines that are too long without you need them 2 lines. Look at what has done here, for example. So now those scalp format goes through. And this is what outline now goes through. So you can just open this. You can copy the API. Look at the API here. Oh, I've actually not, I didn't set my environment here. So like, I currently cannot do anything. Should I deploy this contract here in this class?
I think
Do you want me to
much
deploy
people
it?
are not here for now. We are not much. I think when we have the full class, I don't know.
Okay.
Please let's hold.
But,
Let's deploy on Friday, so then we'll have a full class.
okay. But we can use this. We can either deploy new or upgrade the system. After it does makes everything easy. And we have look at our functions here. These are our real functions. Response. Everything is made visible. So I think this is the end of this class. I'm going to should I push to I can just send the zip back. Okay, I'll push it to GitHub. And I'm going to that will be our assignment for this week. But what you are going to do is not going to be it's going to be another thing. I'm going to make it simple. But I don't because I don't want you to learn the semantics of writing cairo smart contract. So I think that brings us to the end of this class. Now, should we really need to do this? I would love to explain this now. Okay, this is the next thing we need to get into. Contract class and contract instance. Like it's the last thing. So I think this is what we're going to try to use these 4 steps. Yeah. And then we're going to deploy the contracts. And if you want, we're going to interact with the contracts. So, keep practicing, keep doing what you're doing, keep doing that. Everything will feel like it's. So I think this brings us to the end of this class. Have a good night. I don't know what that is. GM, GM.